So now that we've done a couple of examples, let's go into the lecture slides. So flow of control. Unless specified otherwise, the order of statement execution through a method is linear, one right after another. Some programming statements allow us to make decisions and perform repetitions. These decisions are based on Boolean expressions, also called conditions, that evaluate to true or false. The order of statement execution is called flow of control. A conditional statement lets us choose which statement to be executed next. They are sometimes called selection statements. Condition statements give us the power to make basic decisions. The Java condition statements are the if and if-else statement and switch statement. We'll explore the switch statement in Chapter 6. Boolean expressions. A condition often uses one of Java's equality operators or relation operators, which all return Boolean results. We have the equal to, the not equal to, less than, greater than, less than or equal to, greater than or equal to. Note the difference between the equality operator, which is 2 equal signs, and the assignment operator, which is 1 equal sign. An if statement with its Boolean condition. So here's your if statement, and there's the Boolean condition. They're checking to see if sum is greater than max. If it is greater than max, they're going to assign delta equal to the sum minus max. First, the condition is evaluated. The value of sum is either greater than the value of max or not. If the condition is true, the assignment statement is executed. If it isn't, it's skipped. See age.java. So here's an example they have in the lecture. They have a class called age. They created a constant for minor, which is equal to 21. They created a scanner object, and then they do a print statement into your age. They scan in the age that is inputted. They run that to a condition. They're saying if the age is less than minor, then they're going to print out the statement, youth is a wonderful thing, enjoy. And then they print out the statement, age is a state of mind, which is always going to get printed out. The only statement that is controlled by this condition is this statement right here, youth is a wonderful thing, enjoy. And then they have a sample runs where they enter in 47 and they get age is a state of mind. And then when you enter in 12, they say youth is a wonderful thing, enjoy, and then they output age is a state of mind. Logical operators. Boolean expressions can also use the following logical operators, the logical not, the logical and the logical or. They all take Boolean operands and produce Boolean results. The logical not is a unary operator. It operates on one operand. The logical and the logical or are binary operators. Each operates on 2 operands. Logical not. The logical not operator is called logical negation or logical complement. If some Boolean condition A is true, then not A is false. If A is false, then not A is true. Logical expressions can be shown in a truth table. So here they have a truth table. They're saying if A is true or if A is false, then here's the result of not A. So when A is true, not A is false. When A is false, not A is true. You're basically just taking the opposite of whatever it is when you put the not. Logical and or. Logical and expression, A and B, is true if both A and B are true and false otherwise. Logical or expression, A or B, is true if A or B are true and false otherwise. A truth table shows all possible true-false combinations of the terms. Since and or each have 2 operands, there are 4 possible combinations of A and B. So here's the truth table. You have A and B and A or B. So if A and B are true, then A and B and A or B are both true. If A is true and B is false, then A and B is false because in A and B, both A and B have to be true. But the A or B, either one have to be true. Since A is true, then A or B is true. Then the next one, A is false, B is true. So A and B is false once again because they both have to be true. A or B is still true because one of them is true. And the last example, A is false, B is false. So A and B is false because neither one of them are true. And A or B is false because neither one of them are true. Expressions that use logical operators can form complex conditions. So here is a complex condition. Here is the and on one side of the and, you have total is less than max plus 5. On the other side of the and, you have not found. So both of these have to be true in order for the statement to be outputted. All logical operators have a lower precedence than relational operators. So what they're saying is, in this Boolean expression up here, here's a logical operator. It's being evaluated after this relational operator. The not operator has a higher precedence than the and or the or operator. So here's the truth table for the complex expression in the previous slide. So you have total is less than max, and you have found, and then you have not found, and then you have total less than max and not found. So they're using this truth table to determine if this last part is true or false. So if total is not less than max and found is false, then not found is true, then both of these sides have to be true, but only one side of it is true, so it's false. The next line, If total is less than max, it's still false, but found is true, then not found is false. So both sides of this logical operator are false. So this is false. If total less than max is true and found is false, then not found is true. So that means that both sides of this expression are true. So then we're true right here. That's the only time that we're ever true, is if total is less than max and not found is true. Then total is less than max, found is true, so not found is false. So this side of the expression is true, but this side of the expression is false. So it's false. Short-circuited operators, the processing of and or is short-circuited. If the left operand is sufficient enough to determine the result, the right operand is not evaluated. So here is the logical and. So in a logical and, both sides of the expression have to be true. In Java, it's short-circuited. So what that means is if count does not equal 0, if this right here is false, then since this is an and, there's no point in checking this side. This is already false, so we don't need to continue and check the other side of that. The if statement. Now let's look at the if statement in more detail. The if statement has the following syntax. The if is a Java reserved word. Then you have parentheses and the condition. The condition must be a Boolean expression. It must evaluate to true or false. Then you have your statement. If the condition is true, the statement is executed. If it's false, the statement is skipped. Here's a flow chart. So here, your flow of control is coming in. It sees a condition it needs to evaluate. If that condition is true, it executes the statement. If it's false, it's going to bypass the statement. Indentation. The statement controlled by the if statement is indented to indicate relationship. The use of a consistent indentation style makes a program easy to read and understand. The compiler ignores indentation, which can lead to errors if the indentation is not correct. And here's a quote by Martin Golding. Always code as if the person who ends up maintaining your code will be a violent psychopath who knows where you live. Quick check. What do the following statements do? Okay, so let's look at these. So if total does not equal stock plus warehouse, inventory error. Okay, so this is going to set a Boolean variable to true if total does not equal what's in stock and what's in the warehouse. This next one, found or not done, then we're going to print OK. So if either one of these are true, we're going to print OK. So if we found it, we print OK. And if we're not done, we print OK. So here are the answers. So this one says sets the Boolean variable to true if total is not equal to the sum of stock and warehouse. The next one says prints OK if found is true or done is false. The if-else statement. An else clause can be added to the if statement to make an if-else statement. So here is the syntax. You have if, then you have your condition, then you have the statement that you're going to print out if the condition is true. Then you have your else, which has its own statement that's going to be executed if the condition is false. If the condition is true, statement 1 is executed. If the condition is false, statement 2 is executed. One or both will be executed, but not both. See wages.java. So here's an example they have in the book. They have a class called wages. They have constant for rate and a constant for standard, which is the hours in the week and the regular pay rate. They created a scanner object. They created a variable called pay. They set it equal to 0. They prompt the user to enter the number of hours worked. They store that into hours. If the hours you worked is greater than the standard, which is 40, so they're saying if you work more than 40 hours, they're going to calculate your pay with time and a half added on. Else, they're going to calculate your pay to be just the regular rate. And then it'll print out your pay amount. Here is the sample run. So they entered 46 hours worked, so they printed out their gross earnings. Here's the flow chart for the if-else statement. So you evaluate a condition. If a condition is true, you execute statement 1. If the condition is false, then you're going to execute statement 2, which is going to be in the else clause. The coin class. Let's look at an example that uses a class that represents a coin that can be flipped. Instance data is used to indicate which face, heads, or tails is currently showing. See coinflip.java and coin. So here's coinflip. This is the driver class. They instantiate an object of their coin object. They flip the coin object. They output the coin object. They invoke the method isHeads. And if it's heads, they print out you win. If it's not heads, they print out better luck next time. And here's the sample run. They print out that it's tails and print out better luck next time. Here's the actual blueprint class for the coin. They have heads and tails. They have a constructor that will flip the coin. Their flip is basically just choosing a 0 or a 1. Then they have a Boolean method called isHeads that's going to return true or false if the face value is equal to heads. And then their toString is going to print out heads or tails. Their toString is using an if statement to determine if they should print out a heads or a tails. Indentation Revisited. Remember that indentation is for the human reader and is ignored by the compiler. So here they're doing the example that I showed you where in this else statement, since they're not using curly braces, only the first line is going to be attached to the else clause. The other line is going to be outside the else clause. So you have to be careful with this. That's why it's always important to use curly braces. So despite what the indentation implies, delta would be set to 0 no matter what. Block statements. Several statements can be grouped together using a block statement delimited by braces. A block statement can be used wherever a statement is called for in the Java syntax rules. So here they're showing you an if statement with the curly braces. You have two statements that are associated with the if clause. The if clause, the else clause, or both could govern block statements. So here they're showing you curly braces on both the if and the else. See guessing.java. So here they have a driver class. They have a constant for the max, which is 10. They have the answer, they have the guess. They set up a scanner. Then they generate a random number, which is going to be max plus 1. So max is 10, that's 0 through 9, plus 1 will give us 1 through 10. And then they prompt the user, I'm thinking a number between 1 and 10. Guess what it is? They take the user's guess, and if the guess is right, they print out good guess. If it's not right, then they print out sorry, not correct, and they tell them what the answer is. And here's a sample run. I'm thinking of a number between 1 and 10. Guess what the number is? They entered in 6. That's not the correct number. Sorry, the number is, and they print out the number, which is 9. Nested if statements. The statement executed as a result of an if or an else clause could be another if statement. These are called nested if statements. An else clause is matched to the last unmatched if, no matter what the indentation implies. Braces can be used to specify the if statement to which the else clause belongs to. See min_of3.java. So here's their program, min_of3.java. They have num1, num2, num3, and they have min, which is 0. They prompt the user to enter in 3 numbers. He's going to enter in 3 numbers. Then they're using conditions to determine which of the 3 numbers is the smallest one. So they're saying if num1 is less than num2 and num1 is less than num3, then the min number is num1, else the min number is num3. Then on the clause for this up here, meaning num1 was not less than num2, then they're checking to see if num2 is less than num3. If it is, then the min is 2. If it's not, then the min is num3. And then they print out the value. Here's a sample run. They're going to prompt the user for numbers. He's going to enter in his numbers, and then they're going to output the value